A nautical mile is the length of an arc of the equator intersected by a central angle of 1 minute. Using 3,960 miles for the value of the radius of the Earth, express 1 nautical mile in terms of a standard mile. So there's my angle right there. That is 1 minute. 1 minute, if you convert it, is 1/160th of a degree. The radius of the Earth, they said you use 3,960 miles. They want to know what 1 standard mile is. That would be S, my arc length. So let's plug in what I know. S is equal to theta over 360 times 2 pi r, and r is 3,960 miles. Pick up your calculator, put everything in your calculator, and you should get 1.15 miles. Angles on a clock. What is the radian measure of the larger central angle made by the hands of a clock at 7 o'clock? Express your answer as a rational multiple of pi. So they want to know at 7 o'clock, what is that angle there? At 7 o'clock, that angle is 7/12 of, that's a 12, not a 1, 12, 7/12 of a whole circle, or of 2 pi radians. So it's 7/12 of 2 pi radians. 2 cancels right there to 6. So you end up with 7 pi over 6 radians. 82, the arc of a pendulum. How far does the tip of a 5-foot pendulum travel? So that length is 5 feet. That's my radius of my circle. That's equal to. Through an angle of 30 degrees. So there's my angle, 30 degrees. Round your answer to 2 decimal places. Again, and they want to know how far does it travel. So they want to know that length there, which is S. S is equal to theta over 360 times 2 pi r. So plug in what you know. 33/60th times 2 pi r is 5. Plug in what you know. And if you pick up your calculator, you should get about 2.62 feet when you plug that all in your calculator. So take some time, plug in your calculator, make sure you know how to use your calculator properly, because you never know when I am going to let you use it on a test. So you should be at least using your calculator to make sure you get the right answers. Security camera. A camera rotates through an angle of 120 degrees. So there's my angle of 120 degrees. To the nearest foot, what is the arc width of the field of view 40 feet from the camera? So they want to know that right there. What is the arc width? So that's my S. If you're 40 feet from the camera. So again, S is equal to theta over 360 times 2 pi r. So S is equal to 120 over 360 times 2 pi, and my radius is 40. So pick up your calculator and let's see, plug in what you know there. We have 120 divided by 360 times 2 times pi times 40. And when you plug that all in your calculator, you should get, let's see, about, let me plug it in my calculator, hold on, 2 pi times 40 divided by 3. When you plug it all in your calculator, you should get about 84 feet. You'll get 83.7758 feet, about 84 feet. The next one, a Ferris wheel. A Ferris wheel in Vienna, Austria, has a diameter of approximately 61 all the way across is 61 meters. Assume that it takes 90 seconds for the Ferris wheel to make one complete revolution. Find the angular speed of the Ferris wheel. Round your answer to 2 decimal places. And then find the linear speed and do the same thing. So A, angular speed. I know that it goes 90 seconds in one revolution. And remember, on angular speed, so I want radians. I know that, let's see, 190 seconds, or I'm sorry, I have to write that correctly. It goes 90 seconds in one revolution, okay? Because I want per second, seconds has to go on the bottom. So I know in one revolution, it takes 90 seconds. I know one revolution is 2 pi radians. So pick up your calculator, plug in what you know. You have 2 pi radians on the top and 90 seconds on the bottom. And when you plug that in your calculator, you will get about, you'll get 0.0698. And it's radians per second. Point 0.0698. B, I want the linear speed. So I want how many inches or meters or feet it goes per second. Since my diameter is in meters, I will end up with meters per second. So remember, that's what I want. And I know in one revolution, it takes 90 seconds. I also know in one revolution, I will go one circumference. And a circumference of that circle is 61 pi. It's 2 pi r, and 2r is the diameter. So it's really pi times the diameter. There's your formula right there, pi times your diameter. So the diameter, or the circumference, is 61 pi, and this is in meters. So now I'm at meters per second. So let's put it in our calculator. You have 61 pi on the top, and on the bottom you have 90 seconds. And when you put that in your calculator, you'll get about 2.1, you get 129, I'm just calling it 13 meters per second. 88. A bicycle wheels are 30 inches in diameter. If the angular speed of the wheel is 11 radians per second, find the speed of the bicycle in inches per second. So let's see what I can do. I know that in 2 pi radians, I will go one revolution. So now I'm in revolutions per second. And I know in one revolution, I will go one circumference. And the circumference of this is 30 pi inches. So I will have 30 pi inches. And before I put it in my calculator, I like to reduce. The pi's cancel out. 2 goes into 30, 15. And so you end up with 15 times 11, which is 165. And my label on this, when you look at it, it is inches. This is inches per second. So this is inches per second. The linear speed at the equator. Earth rotates on an axis that goes through both the North and South Pole. It makes one complete revolution in 24 hours. Find the linear speed in miles per hour of a location on the equator. Use 3,960 miles for the radius of the Earth. I know it makes one revolution hours. And I know that one revolution is equal to one circumference. And one circumference is 2 pi times r, and that would be miles. So pick up your calculator and put it in your calculator. 2 pi times 3,960 divided by 24, and you will get 1,036.73 about miles per hour. Where am I? 92, the distance between cities. So I want to find the distance from Pittsburgh, which is due north of Charleston. So there's Pittsburgh right there on the side of the on the earth, and Charleston is right there. Find the distance between those. So I know that the Charleston latitude is 32 degrees 54 minutes. So this angle right here is 32.54. I know that this angle right here is 40 degrees 30 minutes. So if I want to find this angle right here, that theta, I would take the difference of the two. And I want to find the distance. The distance is S, an arc length. So that's an S. So remember, S is equal to theta over 360 times 2 pi r. R is 3,960. Pick up your calculator for this one and use the degrees and minutes feature. It'll make it a lot easier. Then you don't have to convert the minutes to degrees. And remember, that was when you push second button, the X button that says angle above it. You can put 40, and then you can do the second button, angle, and find degrees, and then write 31, and then do that same button and find the minutes. And then 2 pi times 3960. You pick up your calculator, and you put in your calculator, and you'll get about 525 miles between the cities. 94. Turkey is north of Israel. So there's a city in Turkey, right up there, that is north of a city in Israel. And it tells you the latitudes of each. So it tells you the latitude. So you have that angle right there from the equator to Israel. The angle from the equator to Turkey. So you could find the distance between the two the exact same way you did a minute ago. Your theta, which would be 36 degrees 59 minutes, minus 31 degrees 41 minutes, over 360 times 2 pi times 3,960. Plug it all in your calculator, and you should get about 359 miles. Difference in latitude. So now it's telling you the arc length. So it's telling you this S here, this arc length of S. It tells you that S is equal to 554 miles. Find the difference in the latitudes of these two cities. So I know that S is equal to theta over 360 times 2 pi r. So 554 is equal to theta over 360 times 2 pi. And remember, your radius is 3,960. So if I pick up my calculator and I take it and solve for the theta, which is the angle between the cities, I will get, let me see, pick up my calculator, divided by 2 pi r, And you'll get 8.015621679 degrees. So about 8 degrees, the difference.